Welcome to Session 9. Percent questions are common on SAT Math, and most mistakes come from using the wrong base. Today we convert percents, use multipliers for increases and discounts, work backward from final values, and combine multi-step changes. The core relationship is part equals rate times whole. 25% of 240 is 60. If the question asks for the rate, divide the part by the whole. If it asks for the whole, divide the part by the rate. For percent change, the denominator is the original value. If a price rises from $80 to $92, the change is $12. 12 divided by the original 80 is 15%. Do not divide by the new value. The multiplier method is fast and reliable. Increase by 20% means multiply by 1.20. Decrease by 15% means multiply by 0.85. For reverse percentage, divide by the multiplier. If a 15% discount leaves $68, 0.85p equals 68. So the original? Successive percentage changes do not add. A 20% increase followed by a 20% decrease does not return to the original. 100 times 1.2 times 0.8 equals 96. A 4% decrease. For a 30% increase, then a 20% decrease, the combined multiplier is 1.04, so the net change is a 4% increase. Repeated percentage growth uses an exponent because each new amount becomes the next base. If $500 grows by 4% per year for 3 years, use 500 times 1.04 cubed. The final amount is $562.43. Percentage points and relative percent change are different. If an approval rate rises from 40% to 50%, the percentage point increase is 10 points. But the relative percent increase is 10 divided by the original 40, which is 25%. Your turn. After a 20% discount, an item costs $96. What was the original price? Pause and write the final price as 80% of the original. A 20% discount leaves 80% of the original price, so 0.8p equals 96. Divide 96 by 0.8, and the original price is $120. Session 9 recap. Percent means per 100. Percent change uses the original as the denominator. Use multipliers for increases, discounts, and reverse percentage. Multiply successive changes in order, and keep percentage points separate from relative percent change. Next, we move to absolute value equations.